Yay! Welcome to the first maths quiz on the channel. This is to consolidate learning about quadratics. So this is how it's going to work. There'll be questions and my workings will be reviewed after that. So it is of course advised to take a pen and a paper right now in front of you to give it a try. So when you see new question, immediately pause the video to give it a try. Sources of questions are taken from CIE AS Level Maths Pure 19709 past papers and Complete Pure Mathematics 1 for Cambridge International AS and A Level book. So at the end of the video, in summary, is it just going to be a piece of cake for you? Is it interesting for you? Or is it just way too challenging? So without further ado, let's just get started with our first question, quadratic inequality. X squared minus x minus 2 is more than 0. So pause the video right now, give it a try, and my workings will be revealed in
5, 4, 3, 2, 1.
So on the left hand side, you can see that we can factorize that. So let's do that. So there's x minus 2 multiplied by x plus 1 is more than 0. We can now sketch a graph to illustrate what is going on. So the roots here is x is equal to 2 and x is equal to negative 1. And we want the portion above the x-axis. So our conclusion would be x is less than negative 1 and x is more than 2. So now what about this? X minus 3 squared is more than 1. Now notice that the title here is difference in squares. So let's see if you can use this in this scenario here. Revealed workings in
5, 4, 3, 2, 1.
Now we can just basically expand x minus 3 squared and then minus 1 on both sides and then factorize if we can. And then we can find the roots and then we can conclude our answer. But I'm going to show you this little method here that's going to be so useful for finding something like this. So 1 is basically 1 squared, gonna minus 1 squared on both sides, and now we can see that this is in the form of a squared minus b squared. So we can simplify to become like that. We can factorize. So x minus 3 plus 1 multiplied by x minus 3 minus 1 is more than 0. Now we can simplify even more within the bracket. X minus 2 multiplied by x minus 4 is more than 0. So in conclusion, x is less than 2, x is more than 4. And actually it's not just about perfect squares such as 1, 4, 9, 16, 25, and so on and so on. But in fact it can be something like that, 5. Because we can make it square root 5 squared. And now gonna minus that on both sides. And then it's once again in the form of a squared minus b squared. So this happens, we can factorize, and in the end, we have x is less than 3 minus square root 5, and x is more than 3 plus square root 5. Fast and simple. So let's turn our attention to completing the square. So pause the video right now, and my workings will be revealed in
5, 4, 3, 2, 1.
Now, the function f is defined by f of x. You can just treat f of x as y. The graph, y-axis and x-axis, that y. The result, the output. So now we are going to complete the square. So we can see the coefficient of x squared is negative 2. We are going to make it such that coefficient of x squared is equal to 1. Like that. Now within the bracket, we can complete the square. So we are just going to compare the red line, the red formula, against our within the bracket line here. So b is equal to 3, so we can simplify to become like that. And minus 3 squared basically means minus 9. Gonna expand the bracket to make it like that. And our final answer is the completed square form. Now what about the greatest value of f of x? Well, since we know that something squared will be a minimum value of 0 or it must be positive, and now we are going to multiply both sides by negative 2, so that will give us a maximum value of 0 and it must be negative, isn't it? So we are going to add 15 on both sides. So this happens. So the greatest value of f of x is 15. So what about this? This is a line and a curve. So pause the video and the workings will be revealed in
5, 4, 3, 2, 1.
Now the line is a tangent to the curve, so that means they intersect once. So since they intersect once, at one point they share the same values for x and y. So that is simultaneous equations. So we are going to let the line as equation 1 and the curve as equation 2. Since they share the same values for y and x at one point, we can let equation 1 is equal to equation 2 so that this happens. And then after some workings, we can find something like that. Ax squared plus bx plus c is equal to 0, where a is equal to 1, b is equal to 1 minus k, and c is equal to 4. Now since they only intersect once, that means that there will be only one real root. So, equal roots here, because there's a quadratic equation. So that means discriminant b squared minus 4ac is equal to 0. So we are just going to substitute into this equation, and we are going to get something like this. And you can see once again, it is a difference in squares. So we can factorize that, simplify, and we get k is equal to 5, or k is equal to negative 3. So what about the coordinates here? So the coordinates, we are just, first of all, just going to consider the case k equal to 5, and then going to substitute that into the quadratic equation just before discriminant is equal to 0. So 1 minus 5, negative 4, simplify, factorize, x is equal to 2. So when x is equal to 2, what is y value? Y is equal to 4. So now we are going to consider the second case, k is equal to negative 3. So substitute, plus 4, simplify and factorize, x is equal to negative 2. When x is equal to negative 2, y is equal to 0. So we have two coordinates, two possible coordinates here. We have 2, 4, and negative 2, 0. These two coordinates are the potential coordinates that the line y equal to kx minus 6 is a tangent to the curve y equal to x squared plus x minus 2. So next, we have some constants here, because there are p and q, and we are going to find the values of them. So pause the video, and the workings will be revealed in
5, 4, 3, 2, 1.
Now the quadratic equation has roots negative 1 and 4, so we can make it like that. X plus 1 multiplied by x minus 4, so that the roots x will be equal to negative 1, or x is equal to 4. Now we are going to expand it, so x squared minus 3x minus 4 is equal to 0. And now we are going to compare this with the equation that they show us. So in the end, p is equal to negative 3 and q is equal to negative 4. Now for b, there's a plus r there, and it has equal roots. So we know the values of p and q, so it's going to substitute in. And now we can see a is equal to 1, b is equal to negative 3, and c is equal to negative 4 plus r. Equal roots, discriminant is equal to 0. b squared minus 4ac is equal to 0. Substitute in, and in the end we get r is equal to 25 over 4. Oh, there's a diagram here. So it seems like this is going to be a very interesting question. So pause the video, and my workings will be revealed in
5, 4, 3, 2, 1.
Now the key here is that the area of the garden is equal to area of the path. So what is the area of the garden? Well, area of the garden is basically x multiplied by x, isn't it? Because it's a square, and the length multiplied by height. Yes. So it is x times x, which is x squared. Now what about area of the path? Area of the path will be the area of the big square minus the area of the garden. So that will be x plus 1 multiplied by x plus 1 plus 1, which is x plus 2 squared, and then minus area of the garden, which is x squared. So area of the garden is equal to area of the path, so we are just going to equate them together. Now we can simplify to become 2x squared equal to x plus 2 squared. Now you can see that there's a difference in squares once again. So let's see how it is going to result in. So x plus 2 plus square root 2x is equal to 0, or x plus 2 minus square root 2x is equal to 0. Going to simplify all of that, and we can see that we have two values of x here. But we reject one of them. Why is this so? Because in this context here, x meters, we are talking about length. So length, we can't have a negative value. We don't have negative 2 meters. We don't have negative 100 meters. We only have 3, 5 meters, like that. So when x is negative, we are going to reject that, because that's not going to happen for length. So in this case, negative 2 over 1 plus square root 2 is negative. Because negative 2 is negative, 1 plus square root 2 is positive. Negative divided by positive is negative. So we are going to reject that answer. So x is equal to 2 over square root 2 minus 1. But it is a surd in the denominator. We don't want surds in denominator. So we are just going to multiply numerator and denominator by square root 2 plus 1. So that the denominator now becomes 1. And in conclusion, finally, x is equal to 2 square root 2 plus 2. This value of x will make it such that area of the garden is equal to area of the path. Oh, there's some fractions here. So this is about more complex quadratic equations. So pause the video, and my workings will be reviewed in
5, 4, 3, 2, 1.
Now we can make it on the left hand side such that there's a complete fraction. So we are going to make it like that, and then minus 3 is equal to 0. Then 3, we can make it as a fraction as well. So it becomes something like that. So on the left hand side, it will be a complete fraction, and on the right hand side, it is equal to 0. Now we know that a fraction denominator cannot be 0 because because we cannot divide by 0. That will be undefined. So x cannot be equal to 0. So in order for the fraction to be equal to 0, the numerator must be equal to 0. So that will be the case. And I'm going to multiply both sides by negative 1 so that the coefficient of x to the power 4 is positive. Now you can see later on that there's a quadratic equation starting to come up here. It's starting to emerge. So we are just going to let y equal to x squared so that this happens. Now this is a familiar quadratic equation that we know how to solve. So we are just going to do that. Factorize it, and y is equal to 8 over 3, or y is equal to negative 1. But we don't want y, we want x. So since y is equal to x squared, just going to substitute in, and we can have two answers here. Now we can see there's one of them that's reject, because x squared must have a minimum value of 0, and it must be positive. But here x squared is equal to negative 1. That is impossible. So we are just going to reject it. So x finally is equal to plus minus square root 8 over 3. That will be the real roots for the equation there. Now this will be the final equation of the video. So pause the video, give it a try, and my workings will be reviewed in
5, 4, 3, 2, 1.
Two distinct real roots. Discriminant must be bigger than 0. So this will be the case. A is equal to k, b is equal to 5, c is equal to 2. So gonna substitute that into the discriminant. So k is less than 25 over 8. Is that the final answer? I can tell you that that is not the final answer, because when k is equal to 0, notice what happens to the quadratic equation. That will make it a linear equation, isn't it? Because 5x plus 2 will be equal to 0 now, and there is only one real root. So k cannot be equal to 0, because once k is equal to 0, it is not a quadratic equation anymore, it's a linear equation. So our final answer is actually k is less than 25 over 8, and k is not equal to 0. So how do you find about these questions? Easy? Simple? Interesting? Or is it challenging for you? Comment down below.